This video covers SAT questions of the day, week 2, 2 problems a day. There are two main parts to this problem. First, we have to translate these words into a math equation. And secondly, we have to remember that we're not solving for x, but solving for 8x. So this is a chart from prepscholar.com, and it shows a bunch of key terms and what the mathematical actions are. So for example, we see the word is, and that shows up here, and that pretty much means the same thing as equals. And we see the words more than, which shows up here, and that pretty much means plus. You should be familiar with many of the terms in this table. So to translate this into an equation, we replace is with an equal sign, we replace more than with plus, and then we would solve. So after combining like terms here on the right, we can subtract 16 from both sides, and we get what 4x is equal to. And it's very easy to divide by 4 and get 2 and think we're done, because we have an answer, x equals 2. But remember that we want to know what 8x is. So you could solve for x and plug it back in, or when you're at this step, that 4x is equal to 8, you could directly double both sides to get your answer. 2 and 3 use this equation, a equals 1052 plus 1.08t. There's some important information to pull out of this paragraph, that a is the speed of a sound wave, in feet per second, and t is the air temperature. The question really asks us to express the air temperature in terms of the speed. So those are our two variables. They're asking us to express one of the variables in terms of the other. So a translation there would be solve for t in terms of a. Notice that all of these answer choices have t equals something involving the variable a. So if my goal is to solve for t, and t is here on the right side of the equal sign, that means everything else on that side I have to move over or cancel or somehow get rid of so that t is all by itself. If you think back to two-step equations and which one I would cancel out first, I would first subtract 1052 from both sides, canceling things out here on the right. Now, your calculator isn't going to help you with a minus 1052, but don't worry, we're just going to leave it like that. And we see this decimal in front of t, and is it hard to divide by 1.08? Well, it could be, but notice this whole answer just shows up here in a. So I've brought down the relevant information for this problem, that a is equal to speed, t is equal to temperature, and this was the original equation. Number 3 asks, at which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So we are plugging in temperatures. These 4 different values would be plugged in here for t, and we want to know which one of them would make a closest to 1,000. So why not actually plug in 1,000. That's one strategy, other than guess and check. And we could solve this and figure out what t should be. Of course, if that seems complicated with the 2 steps, you could just plug all these into this equation and see which one is closer to 1,000. Otherwise, if you subtract 1052 from both sides, you're left with this, and then we divide by 1.08 on both sides. And our actual answer is negative 48.1. Which one of these is closest to that value? Number 4 is a word problem. It's a systems of equations word problem about a food truck that sells salads and drinks for various prices, and they sell a total of 209 items combined, salads plus drinks, and they made $836.50. So if you wanted to try plugging in numbers, you could plug in each of A, B, C, and D. One strategy is to start with one of the middle 2 numbers. Notice that these go in order from smallest to largest, so that'd be a good way to guess. And let's say we started with 93. If we had 93 salads, well, drinks would have to make up the rest of that 209. So 209 minus 93, that would be 116 drinks, because combined, salads and drinks, we have a total of 209. If we multiplied those by their prices, $6.50 and $2, our revenue from salads was $604.50, and our revenue from drinks, $232. If you add those together, you do get a total revenue of $836.50. So we got the answer on our first try by using this guess and check method. The more formal way to solve this would be to set up a systems where the top equation represents the price of the salads, the price of the drinks, and the total revenue. The bottom equation represents the total salads, the total drinks, the total of both. You could use substitution or elimination. Let's imagine we doubled this bottom equation. That way we could eliminate by subtracting straight down taking this entire equation and subtract all three columns straight down. 6.5 minus 2 is 4.5. 2 minus 2 cancels out. And 836.50 minus 418 gives us $418.50. If we divide this by the 4.5 sitting in front of S, we still get the same answer, 93. Number 5 requires you to interpret a histogram. The rooftop solar panel installations in 5 cities. So our cities are here on the x-axis, cities A, B, C, D, and E. And our y-axis goes from 0 to 9. And we can see that there are 9 rooftop installations in city A. There are 5 installations in city B, 6 in C, 4 in D, and 3.5 in E. You can figure those out by following over to that point on the y-axis. So if I was to add all of these numbers together, I actually get 27.5. Now that seems kind of weird to track installations across 5 cities for only 27.5 solar panel installations. That's probably because on this y-axis there's a scale. We could be counting in the tens, the hundreds, the millions, well, probably not millions. Down here in the question they tell you that the total number of installations is 27,500. So if we want to go from 27.5 to 27,500, we have to move the decimal place over 1, 2, 3 times. And now we're looking at 27,500. To move it over 3 times, we have to multiply by 1,000. Number 6 is a quadratic problem, and it involves several different steps that really make you think. The first step is to expand the multiplication of these binomials. You could do so using the FOIL method. I prefer the box method. For the box method, you would take your terms ax plus 2 and bx plus 7 and put them on the outside squares of a box, and then you multiply rows by columns. Bx times ax gives you abx squared. The next row column, bx times 2, gives me 2bx. Ax times 7 gives me 7ax, and 2 times 7 gives me 14. So I can pull these elements out from the box and rewrite it down here. And I'm going to set that equal to my equation from above, 15x squared plus cx plus 14. So if I break this down into parts, 14 is equal to 14. abx squared is equal to 15x squared. And this middle part, 7ax plus 2bx, is equal to cx. Well, there's only so many possible values for a and b that when you multiply these two numbers, you get 15. Outside of 15 and 1, 5 and 3 jump to mind, especially since up here it says a plus b has to equal 8. So that tells me that a and b are going to be 3 and 5, which is tempting to choose as an answer right away. But they want to know what are possible values for c. And I know that a and b, one of them is 3 and one of them is 5. So where I go next is this top middle part, 7ax plus 2bx. And I'm going to try plugging in for a 3, and a 5. And when I do so, I do the opposite for b. So when a is 3, b over here is a 5. And when a is 5, b is a 3. This tells me that 31x and 41x are the possible answers. And since we just want c, the number in front of x, our answer is D. In number 7, they tell us that lines L and M are parallel. So I'm going to mark L and M here. They also tell us that S and T are parallel. So I'll mark so here. We know that angle 1 is 35 degrees. Then we're going to use our properties from geometry about vertical angles, about congruent angles, when we have a transversal that crosses two parallel lines. For example, 35 is vertical to angle 1, and the other two angles are supplementary. They form linear pairs. So 145 plus 35 equal 180. And this pattern actually shows up in all 4 areas of this graph. The same values are repeated over here, and over there by angle 2. So the measure of angle 2 is 145. For number 8, you see a common pattern that shows up all over the SAT. This 3x minus y, you're going to substitute somewhere else later in the problem. And you might have to manipulate the problem to create that situation where you can substitute things. I see an x here and I see a y here. And if I remember some things about exponents, I can do more if I have the same base. For example, I have an 8 on the top and a 2 on the bottom. So I can change 8 to another version of 8, which is 2 to the third power, 2 times 2 times 2. And that's where my 3 comes from. And if I move this equation around a little bit, I can figure out where to do some substitution. So I might first use the power to a power rule, which changes this to 2 to the 3x. And then I can use the quotient rule, which allows me to take the exponent on top and subtract the exponent on bottom. That's where I do my substitution. Since this is equal to 12, I replace it, and I get 12. Of course, seeing these 12s would give you an opportunity for just a wild guess. For number 9, I'll show you the long way first, and then I'll show you a shortcut. So when we have layers of division like that, I might want to break it down and think of 1 divided by, and then look at what's on the denominator separate over here. Because I want to get rid of this addition and turn it all into one fraction. So then if I want to get a common denominator, I'm going to take the fraction 1 over x plus 2. I'm going to multiply it by another version of 1 that includes the denominator over here, x plus 3 over x plus 3. And the same thing with the second fraction. I'm going to multiply it by x plus 2 over x plus 2, which is this denominator, another version of 1. It's kind of like if I was trying to add 1/2 and 1/3. This would become 3/6, and this would become 2/6, and now I can have 5/6, and I just found a common denominator. So now, after cleaning that up a little bit, I have the same denominator for these two fractions, and I can just combine them. So if we go back to the beginning, when I took this bottom part and I divided by this fraction, that's because dividing by a fraction is the same thing as multiplying by its reciprocal. So I could, instead of dividing by 2x plus 5 divided by x squared plus 5x plus 6, I can multiply by x squared plus 5x plus 6 divided by 2x plus 5. And 1 multiplied by this is a little bit easier to me than 1 divided by that, even if they're the same thing. So it turns out this here on the right is going to be my final answer. Then, as promised, here's the shortcut method. Plug in 0. It allows you to cancel out lots of things, which make this problem quite a bit easier. So if I put in zeros for x in the original equation, I'm going to be adding 1/2 and 1/3 to find a common denominator. I'm going to convert these to sixths, where I have 3/6 and 2/6. When I combine, I'm left with 1 divided by 5/6, and the same idea happens. Dividing by a fraction is the same as multiplying by its reciprocal. So this turns out to be 6 over 5. So if I plug in x as 0 for these answers, that cancels out all of this part, and one of these is going to equal 6/5, and it turns out B is the only one that does. In number 10, we have a table of 21 brown bullhead fish, and one of these measurements, the 24 measurement, turns out to be an error. So if we got rid of that piece from the data and we left the other 20 numbers, they want to know which would change the most, the mean, median, or range. So you have to know what these things are. The mean is an average. If you were to add up all the numbers and divide by how many, that's the mean. The median is the middle value. If you sorted all the numbers from smallest to biggest and you crossed off the edges until one number remains, that middle value is the median, and if there's 2, you take the average of them. The range, you take the maximum minus the minimum, or the biggest number minus the smallest number. So if I was to get rid of this value of 24, the mean and median are measures of central tendency. They're going to be somewhere in the middle of these numbers. In fact, the mean goes from 12.5 to 11.9. The median is barely affected, 12 and 12. But the range, which is the biggest minus the smallest, is going to be quite different when the biggest number goes down by 8. So that was your best answer.